Hey guys, we are going to now talk about definite integrals, meaning instead of getting just an equation for an answer, we are going to get a number. And I'm about to tell you what that number means. So definite integrals. Well, first of all, we're looking at equations and graphs. And a graph is like a rate. We have talked about this for a long time with our derivatives. We were finding the slope or the rate. Now, what we are going to talk about is the part that is underneath the curve, because that is the integral. So what this means is your graph is going at a certain rate. So this graph is going at a rate. And then at the bottom here, we're going to say that this is time. Maybe. And what you are finding here, so this is the time interval. And it can be anything. It can be product. It can be, whatever. But for our purposes, to make this as simple as possible, the rate is the time. So from 1 second to 4 seconds, something is happening at a certain rate. And so this distance right here is the rate at those times. And all this in here is the total. So it's like the total, so distance equals rate times time. And so that total distance is the area under the curve. That's what we're finding. And that's what these definite integrals are finding, is the area under the curve. And that's the simplest way I can explain it to you. So let me go ahead and say that the point from point A to point B. So that helps, because here is how you write it when we are finding definite integrals over an interval from A to B. A is the lower limit, B is the upper limit. It's an interval. So the next thing we're going to talk about is we're going to do the easiest thing. So the reason that I had you guys doing some review of area is because the easiest way to find these is if your graph makes a geometric shape, then it is easy to find the area underneath that curve without having to do anything except geometry. You just graph it, and then you find the area. So that's the process here. You sketch the graph. So here, this graph happens to be a half circle. And that's what we determined. And it's only above the x-axis for now. So that's what we're going to do. We're going to find the area under the curve between the x-axis and the curve. That's the easiest way to go. So that's like from, and then the interval, if this is from A to B, and then this would be the shaded region. And so we would find that area. You know how to find the area of a circle, so we would take half of it, and that would be, and the radius for this circle is 2, so that would be easy. So let's do some examples. All right, our first example. So what we are doing is taking the function. This is the function. And so I'm going to rewrite it as y equals 4. In this case, it's just a number, and that's okay. It's just a constant. So I am going to graph that. That is a line like that. And then I'm going to put where x is 1 to 3. That's our interval from 1 to 3. So that's from here to here. So now I'm going to go ahead and draw that and shade it in. So it's going from the curve, in this case a line, down to the x-axis. I have a rectangle. And I know the area of a rectangle is just length times width. So I'm going to figure out what those two dimensions are. It's 2 by 4. So the area under the curve is 2 by 4, or 8. It's as easy as that. If you have a rectangle, your problems are only going to be as difficult as your shape. So let's look at the second one. So my function is right here. It's y equals x plus 2. That's another line. And it is going as x from 0 to 3. So I'm going to graph the line. I'm going to start at 2. And I'm going to go up 1 over 1, up 1 over 1, like that, and down 1, back 1. Now I have to find the interval. So it's going from 0, this line, to 3. 1, 2, 3. So this is a trapezoid. Now I want you to notice that this trapezoid, the two bases, because I'm going to tell you the formula needs the two bases if you forgot, are here and here. So this is kind of a trapezoid on its side. And this is important because we're going to use these later. But this is B1 and this is B2 because the formula for the area of a trapezoid is 1/2 B1 plus B2 times the height. So it's kind of finding a rectangle and two triangles, in this case just a rectangle and a triangle, but it still works out the same. So you add the two bases, B1 and B2, and so this B1 is 2, and B2 is 5. This is actually the height, because like I said, this trapezoid is sideways. It's not resting on one of the bases. So the distance between the two bases is the height, and in this case that's 3. And so now we can find the area. 1/2 2 plus 5 times 3. And that comes out to be 10.5. And that's all there is to it. We don't have any units because we're just using numbers for now. All right. Well, this looks like a strange formula here, but if you put it in your graphing calculator, which you are totally allowed to do, there's your function, square root of 4 minus x squared, and x is from -2 to 2. So when you plug this in, this is where you get your semicircle. And the radius is 2, so this is kind of a small circle. And it looks like from -2 to 2, so we are going to use the entire semicircle there. And you know that the area of a circle is pi r squared, so we are going to do half of that, half pi r squared. And so when we plug our things in, half pi times the radius is 2 squared, and I'll go ahead and write that, r equals 2 for this circle, half circle. So you just plug all this in, and you get 2 pi, or 6.3. 2 more. So I wanted to do one of each type of shape. Pretty much have. Just got one left. Don't know if you can figure out what that is yet, but here we go. So this graph is y equals x, and x is from 0 to 4. So y equals x is that line right there. And it's from 0 to 4, so that's here. So I wonder, there it is, it's a triangle. And that means that the area is 1/2 base times height. And the base is 4, and the height is 4. So I have A equals 1/2, 4 times 4, so A equals 8. Last one. Last one is y equals, if you noticed from the last one, it's probably going to be another half circle, so let's figure that out. 9 minus x squared. And when you graph it, it definitely is a half. There we go. But pay attention, this interval, it's not always going to be the full one. This is from 0 to 3. 0 to 3 is only a quarter of the circle. So it's not a half circle this time, it is a quarter circle. So our area is going to be 1/4 pi r squared, 1/4 pi 3 squared, and that turns out to be 7.1. And that is all the examples I'm going to do. So this should be a nice, easy last assignment for you guys, and we'll really get into integrals when you come back from spring break.